Oh, hi. Welcome to the Abbey Road Observatory. I'm your host, Jim, the filter guy. I don't know about you, but the upcoming Artemis 2 mission has me very excited about lunar exploration. So much so that I dug into my own personal archives to pull out these old Apollo-era lunar atlases, which is the topic of today's video. I'm going to talk all about how these famous atlases were created and the impact that they had on the success of the Apollo mission. I hope you like it. So without further ado, let's talk about the Photographic Lunar Atlas. Welcome to my video today called The Photographic Lunar Atlas, Beginnings of Modern Lunar Study. Those who know me know that I have a keen interest in the moon, not just observing and imaging it, but also regarding the history of the man's relationship with it. In today's video, I am going to talk about an important part of the history of lunar study, and I hope to share my appreciation for this work by those who have gone before us. Serious telescopic study of the moon began shortly after Galileo reported his observations in the early 17th century. Up into the 20th century, almost all lunar study involved mapping and naming of features, a field called selenography. Little or no research was done in all this time regarding the moon's geology or how it was formed. In fact, many scientists believed a large percentage of craters to be of volcanic origin right up until the late 20th century. After World War II, the U.S. increased research in rocketry and other space sciences, a result largely of the German scientists who had immigrated after the war, the most prominent of which was Wernher von Braun. Research at the time was not well organized and poorly funded. This all changed when the space race was officially kicked off on October 4, 1957, with the USSR's launch of Sputnik 1. Everyone was surprised at how far ahead the USSR was in space science. U.S. President Kennedy was not about to lose the space race to USSR. His many speeches, like the famous one given at Rice University on September 12, 1962, inspired all Americans to join in the race, specifically the race to put a man on the moon. He also made sure that whatever government resources were necessary were made available. In his own words, before a joint session of Congress on May 25, 1961, "First, I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish." Great words indeed. So, now that the President, Congress, and the American public were all on board, scientists had to figure out what to do next. With this new commitment to land a person on the moon before 1970, scientists and engineers were sent scrambling. It was suddenly brought to light how little actual information was known about the moon. With less than 10 years to go, one of the first things that had to be done was to learn as much as possible about the moon's physical makeup. Luckily, funding was available to back the immense research effort that had begun. This is where the main character of my story enters. Dr. Gerard P. Kuiper. The Wikipedia entry for Kuiper reads as follows. Kuiper, the son of a tailor in the village of Harenkarspel in North Holland, had an early interest in astronomy. He had extraordinarily sharp eyesight, allowing him to see magnitude 7.5 stars with the naked eye, about 4 times fainter than visible to normal eyes. He went to study at Leiden University in 1924, where at the time a very large number of astronomers had congregated. He befriended fellow students Bart Bok and Pieter Oosterhoff, and was taught by a who's who of now famous astronomers, including Hertzsprung, Pannekoek, De Sitter, Woltjer, and Oort, and the physicist Ahrenfest. He received his Bachelor of Science in Astronomy in 1927 and continued straight on with his graduate studies. Kuiper finished his doctoral thesis on binary stars with Hertzsprung in 1933, after which he traveled to California to become a fellow under Robert Aitken at the Lick Observatory. In 1935, he left to work at the Harvard College University, where he met Sarah Fuller, whom he married on June 20th, 1936. Although he had planned to move to Java to work at the Boscha Observatory, he instead took a position at the Yerkes Observatory of the University of Chicago and became an American citizen in 1937. In 1949, Kuiper initiated the Yerkes-McDonald Asteroid Survey, which ran from 1950 to 1952. Kuiper made many achievements in his professional career, including discovery of the moons Miranda of Uranus and Nereid of Neptune, discovery of carbon dioxide on Mars, discovery of Titan's methane-rich atmosphere. He pioneered airborne infrared observing in the 1960s, was the first to suggest the existence of a population of icy bodies beyond the orbit of Neptune, which we now call the Kuiper Belt. He helped design and was second director of McDonald Observatory after Otto Struve, and spent a large part of his career at the University of Chicago and the associated Yerkes Observatory. In 1960, Kuiper left the University of Chicago to come to the University of Arizona in Tucson. He came to Tucson in search of more freedom in his research and to take advantage of the great observatories of the U.S. Southwest. Upon arrival, he founded the Lunar and Planetary Laboratory, a community of scientists dedicated to solar system studies, including the Moon. This occurred at a critical time, as the Apollo mission required real data on the Moon at a time when no one had really been studying it. Government and public support for the Apollo program meant Kuiper was able to secure funding from the U.S. Air Force to start detailed photographic surveys of the Moon. The objective was for the LPL to publish a comprehensive series of lunar atlases, initially from the existing photographs, then, later, from the new survey photographs, the purpose of which was to give researchers a common basis for their lunar research. In all, Kuiper's group published 4 atlases. The namesake Photographic Lunar Atlas, followed by 4 supplements: the Orthographic Atlas of the Moon, the Rectified Lunar Atlas, and the last 2 supplements in a single atlas called the Consolidated Lunar Atlas. The first atlas, called the Photographic Lunar Atlas, was published in 1960. It was a collection of lunar images from 44 fields covering the whole near side face. The images were selected from thousands of existing photographic plates from Mount Wilson and Lick observatories in California, Pic du Midi Observatory in France, McDonald Observatory in Texas, and Yerkes Observatory in Wisconsin. These images originally being taken between 1901 and 1959. The atlas was issued as a box set of 212 prints, 17 inches by 21 inches in size, in black and white. The large print size and number of fields was intended to encourage use of the atlas right at the telescope. The first supplement was called the Orthographic Atlas of the Moon. It was also published in 1960, and it showed the best photos from the previous atlas with a rectangular grid overlaid to allow for the accurate location of features. This atlas was published as a folio-style book with 29 18-inch by 21-inch prints. The second supplement was called the Rectified Lunar Atlas. It was published in 1963 and showed images of the near side of the Moon with 30 fields as viewed from directly overhead. This was accomplished by projecting existing lunar photos onto a 3-foot diameter sphere and then rephotographing from the appropriate position. This atlas was published in a folio-style book with 142 18-inch by 21-inch prints. The last two supplements were published in a single atlas called the Consolidated Lunar Atlas. It was published in 1967 in the form of a boxed set of 227 17-inch by 21-inch prints. The images for this atlas came from the systematic re-photographing of the Moon at higher resolution than achieved previously. The work was performed by the LPL using the telescopes at the Catalina Observatory in Arizona and the U.S. Naval Observatory in Washington, D.C. Kuiper's lunar atlases were important because they provided a much-needed foundation upon which other lunar researchers could build and a common frame of reference when sharing observations between scientists. In the course of publishing the atlases, the LPL developed a number of new technologies, including the method of rectifying lunar photos that I mentioned earlier, as well as a number of different large-format printing processes that were needed to accurately reproduce the detail found in the glass photographic plates. The lunar research that these atlases supported, as well as all the other work done by the LPL, was instrumental in the success of the Apollo program. The atlas also resulted in some direct discoveries, one of the major ones being the existence of the multi-ring impact basing Mare Orientale, which up until this point was just thought to be a ridge of mountains. Surprisingly, the atlas was still used frequently up until about 10 years ago. You would often see images from the Consolidated Lunar Atlas in Astronomy Magazine, on the Lunar Wiki, or in other books and online articles. Use of images from this atlas has since been replaced by the much superior images captured by the Lunar Reconnaissance Orbiter. These atlases are all long out of print, and finding used printed copies is very difficult. Most are hidden away somewhere in university or professional observatory libraries. Electronic versions of 3 of the atlases are available online at the links shown here, from the Lunar and Planetary Laboratory at the University of Arizona. In summary, I personally regard these atlases as an important piece of history. They were published at a time when serious scientific study of the Moon was just beginning, and were an important stepping stone along the way to putting a person on the moon. These atlases are also a reminder of the long heritage of discovery coming out of the LPL, which continues to this day. I have been lucky enough to find print copies of 2 of the atlases mentioned here today, and I have had fresh copies made of the other 2 from the electronic versions, the reprints being about half the size due to the high printing and binding costs. What do you say we have a closer look at them? So this is the first atlas in the series, the Photographic Lunar Atlas, released in 1960. It is in a large bound box. This is a cloth binding like you'd find on a book. Let's open her up here. So when I bought this used off of eBay, there was quite a bit of damage on the box. I had it sent to a bookbinding company and they repaired it, so that's why there's a mismatch in the color here. So luckily just the box needed repair. The contents were all in pretty good shape considering their age. So all of the atlases had a foreword of a sort of like a guidebook explaining everything that was done. So in this particular case, explaining, where all of the lunar images came from, process that was used for selecting the images, process for dividing the moon up into different zones, all that sort of thing. It's all captured. Some numbering of craters listed alphabetically. So each atlas comes with sort of this similar foreword. The first section of this atlas has some overview type plates. So these are high resolution printed 17-inch by 21-inch plates. And you can see that table of numbered craters corresponds to this particular image of the near side. There's also how they've divided the moon up into 44 different fields so that the pictures are organized based on these definitions of areas. There is some handwritten notes in the margins suggesting to me that this atlas was actually used at one point by a observatory or a university. So yes, there's a number of overview shots here. Now one thing that is consistent is there's images taken at different lunar phases. So this is full moon phase. This was a first quarter phase. And then the annotation on top of that. Well, I guess that's closer to quarter moon there. First quarter, annotated. Last quarter with the annotation. Then finally last crescent. So waning crescent and then annotation. So that's sort of the overall guide to the main features that would then be zoomed in on in each of these different sections. So there's dividers here that go from A to, where does it go to, F? So that's how many rows of fields there are. And then those get broken up into numbered areas up to 7, at least for this particular row. So you can see the quality of the images that were produced. Both the photography at the time was the best that was available. So this are images taken between 1901 and 1959. And then the printing at this size to this resolution was a technology that had to be developed by Kuiper and his team. So like I said, there's 3 of everything. There's sun from one angle, sun from the other angle, and then sun from directly overhead. Each zone is presented in the same way. So a big example of this is Crisium, Mare Crisium, at 2 different sun directions. And there's a 3rd direction and another. Sometimes there's insets in cases where I guess the original photo wasn't of high quality in that region, so the inset in some cases. So a lot of work to compile all of these photos for the different phases of the moon, for all the different regions, out of the thousands of glass plates. So these would have been all from glass photographic plates, developed and into a printable format. So pretty impressive for the time. I'll just quickly flip through some of these. You might recognize so that this is upside down. The label here at the top, but the lunar image is upside down. That's because this was printed with the assumption that somebody is going to be at a telescope looking through an eyepiece with an inverted image to look at. So that's why. I think it's kind of neat to go through all these images, looking at areas of the moon that I'm familiar with from my own observation, and compare the quality of what was available then to what I'm able to achieve now with my amateur equipment, using the lucky imaging technique. The idea of collecting thousands of frames and then allowing software to pick the best ones and align them to create a much sharper image. That was a technique that didn't exist back then. This would have been a single exposure on a glass plate. So if you had good seeing, you have a good image. If you don't have good seeing, then you have a bad image, and that's all you have to choose from. So interesting. So yeah, I won't belabor any longer going through the rest of it, but it's just going section by section through the moon. Here's Plato. So quite a collection. There's 212 of these plates. So each one of these copies is four images on one piece of paper. So 212 total images of the moon in this collection, plus all of the preamble plates that I showed you at the start. Quite a impressive set to have on your desk, I must say. Anyways, so yes, so this was, I was lucky to find this available for sale on eBay. Normally you don't find them for sale. They're locked up in a library, a museum, or observatory somewhere, collecting dust presumably, but yeah, you don't tend to see these for sale. What you do see though is, at least on eBay, I've seen people that take each sheet and sell each sheet by itself, which is a bit, I don't know, it's a bit sad to take apart such a great collection and sell it out piecemeal, basically destroying that collection forever. They'll never be back together again. So anyway, that is the first atlas. Moving on to number 2. So this is the first supplement to the atlas, the Orthographic Atlas of the Moon. It is in a, it's not a box, it's a book, sort of a portfolio style book, but still in the same 18 by 21 inch size. This one was in, the cover is a bit stained and dinged up, but the contents are in pretty good shape. Again, considering how old it is. I found this also for sale used on eBay. So as with the first atlas, there is a bunch of preamble discussing how the how the atlas was brought together, who worked on it, the techniques that were used. In this particular case, there is some maths discussing how they constructed and applied the reference grid over top of the moon. Some overview shots again showing sort of the main crater features, as well as how they've broken this atlas up into zones. So this doesn't cover the same extent as the first atlas. It only covers this central region, I presume because this is where it was reasonable to draw over top the reference grid. In the limb areas, it would be a lot more difficult to do that. And then here are some of the example plates. This is around crater Posidonius, and you can see what they've done. This is not a rectilinear, it's not right angles from the perspective of the paper. It's drawn with reference to the curvature of the features that are in the picture. So quite a technical task to do, to be honest, to figure out how the the latitude and longitude lines of the moon project onto photographs of the features. So a lot of work went into doing this. You can see the names of the people who compiled this up here. Arthur and Whittaker. Whittaker was one of Kuiper's main man in this project. He did a lot of the work associated with assembling these atlases. But you can kind of see what they've attempted to do. They've taken photographs and applied these reference grids, the purpose of which was to allow astronomers to more accurately determine the size and location of features on the moon, an attempt to start figuring out, where everything is, maybe how things are created, that sort of thing. So figuring out the size of features, relative location, that sort of thing. So again, fascinating atlas. A lot of effort went into producing this atlas. Like I said, drawing these grid lines over top of existing photographs is no mean feat, to be frank. So very impressive. Again, it's upside down because the expectation is you'll be looking at this map while you are at the telescope. So there you go. That's supplement number 1, orthographic atlas of the moon. Moving on to number 3. Okay, supplement number 2, the third atlas in the series. It's called the Rectified Lunar Atlas. It was released in 1963. I was not able to find a used copy of the original printing of this anywhere. So this is a reprint that I had made using the PDF files that you can download from the LPL website. I had it printed and then bound using the same company here in Ottawa that did the repair on the Photographic Lunar Atlas box. So they did a very nice job. So as with the first two, this atlas has a preamble discussing how the atlas was made. It's showing some of and describing some of the technical problems that they had and how they figured out how to project a photograph onto a reflective sphere and then rephotograph it from a different angle. That's how they achieved the effective view of being directly overhead of these different features on the moon. It's a pretty cool solution to the problem when you think about it. In this case, they have divided the moon up into only 30 fields. This is the definition of how they've divided the moon up into different zones. The original of this, by the way, was printed as a folio book, just like the first supplement was. But again, 18 by 21 inch size prints. This is only 11 by 17, so just a bit over half scale. So yeah, as you flip through, it's kind of a fascinating book to flip through, because if you've been a long time observer of the moon, you grow accustomed to a lot of these craters and how they appear from our perspective here on Earth. And especially around the limb, they are typically foreshortened because of the perspective, so they look oval shaped. But in this atlas, like here is up in the northern part of just north of Mare Serenitatis, and all of these craters here, especially like Aristoteles, we see them as ellipses from our perspective, but here the camera has been positioned over the projected image to give us a view of like this crater directly overhead, and indeed it is round. Pretty much all of the craters on the moon are round, and that in itself was an interesting discovery, because then it implies that regardless of the angle of the trajectory, you know, within limits, regardless of that angle that a projectile hits the moon, it results in a round crater. So that has a direct implication on what the physics involved is in the creation of those craters. So pretty neat. Yeah, Struve, Eddington, these are normally way up on the limb. You don't see them round like that. Or even Chrysium, you don't normally see it perfectly round. I think it is shown here. So a fascinating atlas. Again, a lot of technical expertise went into creating this. The whole idea of projecting and rephotographing from a different angle was brilliant, I think. Great work by the scientists at the Lunar and Planetary Laboratories, Kuiper and his team. So yes, that is supplement number 2. All right, the 4th volume from this atlas, supplement number 3 and 4, is called the Consolidated Lunar Atlas. This is perhaps the one that most people are familiar with, because it was the most recent, but not by much. Published in 1967. It is also not available online, at least when I was looking for it. So this is again another reprint from the PDF file that you can get from the LPL website. The link is earlier in my talk. So again, I printed 11 by 17, but the original was 17 by 21 inch, and it was released as a box set of 227 plates. So the same format as the first atlas that we looked at, the Photographic Lunar Atlas. The only difference being that all the images in this atlas are new photos. So photos that were collected by the LPL team over the course of the early to mid 60s, that then went into creating this particular volume. So the best photographs of the moon possible at the time in the mid 60s. So again, there's a preamble talking about how it's all done. There's some talk here about the lunar orbiter, which I guess they use some of the lunar orbiter data as well to help put this together. Quite a bit on the lunar orbiter, I think, for all the close-up photos. Excuse me. And here's some of the base data that came from the lunar orbiter. So they've divided the moon up into the same 44 zones like the original atlas. They're all kind of labeled here, sort of a map you can navigate. Some features are shown up close, like here's a picture of the crater Clavius. And as with the first atlas, they make an effort to show features at least 3 different solar illuminations. So here are the craters. I believe this is one of them is Atlas, maybe. So here are the lights coming from this direction. Here are the lights coming from this direction. Here the lighting is slightly different again. This might be a different crater now. So yeah, they provide views of the same area at least 3 different illuminations. So you can see here the low sun angle this way, still this way. Now the sun angle is this way. And they typically have one directly overhead, so they're very shallow solar angle. And looking at these photos, I know they're only printed out 11 by 17. They should be printed out, almost twice this size. But the quality of the images they were achieving was quite impressive. I and other amateurs can do better than this now using Lucky Imaging, but keep in mind this is not Lucky Imaging. This is a glass plate, single exposure. So the quality of the optics and the cameras and the steadiness of the air and the locations where this data was collected was very, very good to get a single exposure with this kind of detail. And that's the quality of these images is one of the reasons why excerpts from it were used for many, many years after the Apollo program. The Lunar Wiki often used photos from this atlas. Astronomy Magazine often use images from this atlas, just because, for online or print media, this is excellent resolution for that application. So yeah, until the Lunar Reconnaissance Orbiter was put into service, these were the best lunar images publicly available. So they got a lot of mileage out of the contents of this atlas. So very cool. So that is the 4th and final book in the Atlas series. I hope you enjoyed having a look. If, by the way, you have enjoyed this video or the other videos that I do, please feel free to click the like button down at the bottom of your screen. And if you want to keep up to date with everything the Abbey Road Observatory is doing, maybe you'd like to subscribe to the channel. All right. Well, this is Jim, the Filter Guy, signing off, wishing everybody clear skies.